5 slide, what I do with Kamailio, for how long, what version, and all this kind of interesting information about their deployment. Not to make it long, Markus.
Thank you. Yeah, as Daniel said, we will see 9 people telling about their Kamailio infrastructure and things around, some infos about the companies or the products. So I think it's a bit tough. I told everybody to train in front of the mirror and track the time. So hopefully the next session will be on track, but we will see. So first speaker is Vasily from Ukraine, Wild Ikes, and 5 minutes starting now.
Okay, thank you. Good day, everybody. I'm glad to be here. I'm Vasily from Odessa, and it's even more delightful to share some ideas of how we use Kamailio in our system. So, WildX. WildX is a multinational company that develops the unified communication solutions and VoIP products. We rely on a network of certified partners who deploy our systems for our customers. The company started in 2003 and the same year opened the R&D in Odessa, Ukraine, and through the next year opened offices through around Europe and then in North America. So, Kamailio on PBX. Why do we need it? PBX and Kamailio. Sorry. Okay, excuse me. So let's look through some features and main points. Why do we need Kamailio? The first one is DOS protection. Yesterday it was already mentioned. We rely on HTables and we ban unexpected users. Our clients can use different hardware and software phones, and among them we have a WebRTC phone. For it we use WebSocket and RTP engine models, and RTP engine as daemon. Kamailio behave as a registrar, and we use register and user log models, and we use parallel forking for all of registered devices. Kamailio is a presence server, and we have presence-related models. It is presence dialog info, presence MVI, and presence reg info. For mobile devices, we implemented sophisticated push logic. Thank you for Daniel and Federico Cabidu for their insights from previous conferences. We used them. In some points, I think our logic is even more powerful. I'm kidding. So, to evaluate script performance, we use Benchmark. It's another great tool, and it's cool to find the bottlenecks and to make the script better. And last couple of weeks, as we chatted yesterday with Alex Dubovikov, we are playing with Homer and with the SIP trace model. We have a lot of another stuffs, but the time is limited, so just move on. If you are interested, come to us, we will share. Move on. As I said before, we sell PBXs, and we behave as we behave as operator for our clients. And on the point of view of architecture, how it looks like. So we have a cluster of Kamailio nodes, as you see on the slide. All the PBXs can interact with them via an APTR SRV DNS records. We do not have persistent connections. And for billing, we use CGRAID's core. CGRAIDs with Kamailio are connected via a WAPI model. And for signaling tracking and for troubleshooting, we installed Homer. Looking through the timeline, we started using Kamailio in 2010, and it was 3.0. And through the history, you can see versions we tried. We tried to be up to date, and the version that we The version that we use now on our PBXs is 5.0.8, and we plan to switch to make major update to 5.2, I think in the near future. So, can we surprise you more? Let me try. We can claim that Wildex has one of the biggest number of installations worldwide, as every PBX has a Kamailio on board, and we have more than 30,000 PBXs. We have such number of Kamailio deployments. As Kamailio is a rock-solid solution, and our system is ready for wide application, we have I think, big installation on the point of view of PBX usage, and it is a network of PBXs with 40,000 users network for one client. As we have a lot of PBXs, a lot of users, and all of them have a lot of resources, requests, we have huge config, and it is 6,000 lines of configs. And we try to contribute time to time to source code, and for example, we had contributed handle loss TCP and an APTR query. It's time, yes. I wanted to say thank you to Sandro Gauci and Dan Bogos for helping us. Yes, thank you guys.
Thank you very much. It's tough, right? To do it in 5 minutes, tough. I forgot to mention, we don't have a Q&A session yet, but grab the people later at the social event or on the breaks and ask the questions you have. Next on stage is Yoseop. Paolo? Yes. Your 5 minutes starts when James pushes the button.
Okay. Thank you. Hello, everybody. Today I would like to take my 5 minutes to talk about how we integrated Kamailio in our platform. Yoseop is a VoIP platform as a service based on Docker and Kubernetes. Today we have a lesson about Docker and Kubernetes also. It's a platform scalable, self-healing, multi-tenant, and geographically distributed. On the bottom of the slide, you can see the video of the last year presentation of the project. Let's see how it's defined the project. We have an edge layer, the only one that is touched by outside, reached by outside, the proxy layer. Then we have a routing layer where the main business logic in terms of SIP happens. Then we have the application layer, we name TPS, the media layer, and every stateful data that resides inside the data storage layer is handled by an API layer. Then we created a connection to the routing layer to our billing ecosystem. And every configuration and update is handled by an orchestration layer able to talk directly with Kubernetes API and to deal with all the modules. But let's see the same diagram in another point of view, in a point of view of signaling and media, in a simple end-to-end call. As you can see, we have implemented Kamailio in the proxy layer, then also in routing layer. And yes, we use asterisk for the application layer, and of course, media is handled by RTP engine, pretty common. What was the goals we have achieved to be as stateless as possible, because this is the best way to gain the best from Kubernetes and microservice perspective. We created an orchestrator, and every pod has an aligner able to reach information from the orchestrator that talks directly with Kubernetes API, handle events, and update configuration and hook Kamailio, for example, to update or reload modules, or to update, for example, hash table data. We implemented the networking layer with low level, low latency, and no net. And thanks to the help of Daniel, we in the routing layer, we implemented on-demand dialog retrieval for failover stuffs. We use DMQ as sharing data replication for user location and hash table. And we wanted to have multiple networks inside of pods in order to isolate SIP and RTP traffic from other services. And for UDP, we use edge balancing using Anycast IP. About the billing integration, we have written an agent service that uses the HTTP async module with JSON RPC. But about details of Evo billing, I will leave my colleague Fabio that will talk about tomorrow afternoon at 3 p.m. And last slide. Last year, we had the opportunity also to participate to the fantastic Dangerous demo. And we were able to start our first test call in less than 2 minutes and 15 seconds. So don't forget to see the Dangerous demo tomorrow. And what about today? This is a screenshot of some days ago. I did some days ago. And we were able to deploy the EvoSIP stack in less than a minute. And in less than a minute, we were able to reach the Anycast IP announced by Edge Router using the OSPF dynamic routing protocol. And as you can see, the edge layer is able to get the endpoints of the routing layer. So if you want to see a live demo, just bring me outside at the coffee break. And more or less, that's all from me.
Wow, in time. Thank you. So next will be Sebastian from German Telecom, talking about infrastructure.
Thank you. Yeah, co-founded in 2015, closed down 2018. And we essentially had a communication app that ran on top of the telephony network. We used a commercial CPaaS stack, amongst other things. And shortly before DT decided to close the company, we were wondering how to save some money, how to do something interesting for the team that remained there. And essentially what we wanted to do is we wanted to replace the stack that is shown here in orange, where our application ran on. So we used Candy.io as on top of a CPaaS, of a private CPaaS, delivered by Candy with their own core and interconnect. And what we wanted to do essentially is make that our own, based on open source, with an SDK on client side, using SIP mainly, and to interconnect that with our partners. And the stack we achieved that with was mainly using components we were using. So we ran off AWS. We deployed the entire infrastructure of AWS. Some things we could not do with Kamailio directly. We deployed Lambda functions behind an API gateway. As I mentioned already, we used some client-side SDKs. We tried to remain open source. On iOS, it was not that easy, so we chose PortZip, and then an engine stack on the right side that I want to explain a bit in detail. So what we've done essentially is we deployed as single machines Kamailio, RTP engine. Together, we had CodeTurn as well for handling NAT, network address traversal, and we used Humor for doing monitoring and mainly troubleshooting. All of that was connected to an iOS app using PortZip, a browser application using JSZip. The iOS app was connecting using TLS, the JSZip was connecting using WebSockets. And on the other side, we had outbound SMS on Nexmo, where we just needed to switch the existing integration using a simple REST call. We used the HTTP client module for that. The DT trunk termination that we were using was basic SIP and RTPs. That was also no problem. Inbound calls we received from Voxbone, so that was also rather trivial to just reroute it to our stack. A bit of a challenge was the inbound SMS, because we just were receiving a webhook from Voxbone, and we didn't find it that easy to integrate. So what we did is, as I mentioned, we used server-side JSZip, some simple Node.js REST API that was running as Lambda function, and whenever it was invoked, we basically sent via a SIP message on behalf of that client that was called. So we instantiated them, we sent a SIP message to the client on behalf of the sending party, and we delivered it to the application. All of that ran behind it. So we used the MySQL database also as managed AWS service, and all of that we did with mainly 3 people. So we had 1 person or 4 people, 1 person responsible for that main stack, 1 person doing this, 1 iOS developer, 1 web developer in approximately 2.5 months. So it was quite interesting, and 2 of the things I would say we took off as positive and negative, or rather as still open challenge. Very positive was that it was very quick what we did. It was not that advanced of a setup, so we didn't have yet orchestration, automation, or somehow integrated in our Kubernetes infrastructure. It was simply simple AWS instances, but nevertheless, to get it working, to just, let's say, take out the old module, so also justify our modular way, take out the old CPaaS, put in, let's say, a client-side module, the server-side infrastructure. We were really quickly to getting on-net voice, getting break in, break out for PSTN and SMS, having, of course, on-net calls working as well with video. Was quite okay. We had a bit of a challenge between bridging iOS and web, mainly also because the stack expertise on the development stacks were not that low level using the CPaaS SDK as they were with now you dealing directly with SIP and RTP and some of the challenges that we had around that. And the last thing that where we really saw, let's say, some improvement potential was the overall programmability. So if you wouldn't want to speak the language of Kamailio directly, or if you really want to mesh up, let's say, also on the back end, the things, the call control and other things you can do on top of it, we developed this kind of adapter, but we really saw this to be improved, and are looking forward to discussing these parts. So together, I'm here with Martin, my former CTO, and myself to catch up with you about that. 5 seconds left, brilliant.
5 seconds left, brilliant. Thank you very much. So next on stage, your captain, Sebastian.
Hi, we're Sipgate. First of all, we like numbers. We are almost 180 people working all in our fancy office in Düsseldorf. Have about 20 teams. All work in an agile environment. Up to the it goes down to the kitchen, which have a planning each week and stuff. We have 12,000 people going through our office each year, and last year we had more than 8 million liters of coffee that our machine served. And we are a operator carrier, and we have 4 PSTN networks, 2 mobile virtual networks, and a transit network. And a lot of Kamailios in there. You see there are 4 our PSTN networks. There's one that already has an NGN interconnect, and the 3 others still have SS7 interconnects. And behind there, or for the NGN interconnect, we use a Kamailio as a load balancer, and behind that some SBCs, Yate, asterisk stuff. And for the SS7 interconnects, we still have some black box hardware like the media gateways from audio codes, but they are controlled by other open source software, Yate. And then we have a transit network, which gives us other connections to the outside, mainly to other carriers. And we have a mobile network. We operate as an MVNO and only use the radio stations of the Telefonica network. How's that all connected? We're of course our main setup is still the Sipgate network, and we have drawn it like a bridge here, which connects all those networks together. And of course we only use zip because we are Sipgate, and we had to learn the SS7 later than we already knew zip. Yeah, the Sipgate network, yeah, we have a lot of customer load balancers. We have some proxies there where people register against or that route our calls and are the main workhorses. We have Humor in there. We use Kamailio for lawful interception, and one of our products is the satellite product, satellite, which is basically was the same or is the same concept as Immer was. Only ours is not shut down. Yeah, we use the Kamailio to push those devices to wake up and to work. Thanks for the community that you offer all those crazy things that we can do with Kamailio. One crazy thing is, yeah, we use we have a real-time zip online status, and since we don't want the proxies to write into the database and depend on database being online and stuff, we just forward all those registers to a different system, which writes it into the database every 5 seconds. And so whenever you plug in your device and let it register, you see it on the website after maximum 5 seconds. And just some numbers at the end. I just counted this morning. We have 87 instances of Kamailio running, only on like 25 machines. So a lot of instances on the same machines. They are all deployed by Jenkins, so no handwork there. Everything is at least on 5.1. The newest system is on 5.2, using a JavaScript Kimi setup, tested TypeScript code, and one system with a bluer code, and the biggest config, still old style, is 3.5K.
Thank you very much. 15 seconds over. So, Matthew. Hi.
Hello.
Where do you come from?
Hello, I'm Matthew from NextWay. I'm also joined with Giacomo Vacca, who I'm sure some of you know, and Andrew at the back.
Are you ready?
Yeah, go.
Okay.
So I'm a system engineer at NextWay. In terms of what we do voice API stuff, so controlling calls over HTTP. The idea being that a developer can interact with voice with their apps without understanding SIP or telecoms or any of that stuff. We also offer messaging APIs, so currently we're tied in with WhatsApp, Facebook and Viber. So again, that's all over HTTP. We do SMS, that's kind of how we started out. So inbound, outbound, short codes. We've got kind of global reach and can get numbers for almost anywhere. And then on the voice side, we do the traditional SIP trunking and DDIs. So topology-wise, this is fairly simplified. This is just one of our data centers. We're in several, but topology-wise, it's basically mirrored in each. So we use Kamailio as a sort of standard edge proxy. It's doing things like the authentication, load balancing, and failover. We have Asterisk in the core, which is sort of dealing with the billing and some of the SIP trunking stuff. And then the newer voice API stuff is all FreeSwitch. Kamailio doesn't touch the media. It's all going through Asterisk. And at the moment, we loop the media from FreeSwitch through Asterisk before it goes out to the customers. And then we've also got a few legacy applications that we're hoping to get rid of eventually. So cool stuff in terms of Kamailio. We use GeoIP, so customer requests are served by the closest media server. We use DMQ, so all the customer edge proxies are calculating CPS. Those results are distributed using DMQ, and then we basically rate limit anyone that's being naughty. We use a lot of API requests to our back end. So all the authorization is done by the edge proxies. We verify the credentials over an API. We also check if an account's enabled and in credit, so we can drop traffic before it reaches our core, basically, if it's not going to work. We also check if the number exists, or does it route to API or one of the sort of traditional SIP interconnects. We also use Lua on the carrier side, so we use that for normalizing local formats into E164, adding and removing pluses, prefix, and stripping country codes. And we also use console, so the free switch backends announce themselves to console, and from there they're automatically added and removed from the dispatcher. How we test and deploy Kamailio, I guess this could do with a whole presentation on itself. We have a NextWay playground environment, so we can spin up an isolated replica of the production environment within AWS, even multiple per developer. You can tear them up, spin them up, tear them down, and test basically what you need. So it's fully automatic, it's provisioned using Terraform and Puppet. You can deploy development branches from Git or make ad hoc local changes, and then you can run automated tests. So that's where you kind of play with ideas and see if it's going to work. From there, it then goes to our QA environment, which is a bit closer replica of our production environment in terms of hardware and network. So we'd put it on there and go through our final testing, and then we deploy into production. So it's all deployed using Puppet. We generally only reload what's necessary, so if we make a change to the Lua, we'll just reload the Lua. If it's a dispatcher change, we'll just reload the dispatcher. And in theory, deployments are scheduled from the master branch. It could be automatic, but we tend to babysit at the moment. And numbers, so we're using Kamailio version 5.1x. We have 16 instances in production, several in QA, and potentially hundreds in MPE. I think during any one day, we generally have about 100 MPE environments on a day. So server specs, it's quite modest. It's 8 cores and 8 gig of RAM. And then CPS. So CPS, you know, on a normal day, we'd see sort of peaks of 177, but the load testing sort of indicates that in theory they do 400 to 500 CPS. And that concludes my talk. If anyone wants to come chat to us, we have some coupons and vouchers for credit. Speak to Giacomo or Andrew or myself. We'll sort you out with that. So thanks very much.
Thank you. And in time, it's amazing. So, Dennis, is it switched on?
Yes.
Okay.
Hello. Thanks for pushing me to do this presentation. I feel very honored in this circle of much, much bigger deployments and other presentations about how Kamailio is used. So we're via networks. This direction? Okay. A company based in Berlin, founded already, 2008. So also having had the 10th anniversary last year. What we do is, cloud PBX services, just like everyone else. But what's up in the queue, which is really nice, is that we will release a UC client based on Riot Matrix, high up in the news for very good reasons, is our opinion. And other than that, we're also kind of active in the community, hosting TATAC, for example, in Berlin. It's a global telecom application development hackathon, or the newly founded Berlin RTC meetup from Daniel will happen at our location, hopefully next time. Yeah, Kamailio. Also a long-term user of Kamailio, starting with version 3 back then in 2012. Today still on version 4.4 for some reasons, because we are too comfortable with this setup, so we will touch it this year. Of course, you can also just use Kamailio in an easy way, not so complicated. So what it does for us, of course, is just being the proxy towards our endpoints, giving us TLS encryption on the edge, and domain-based routing, thanks to an awesome tutorial from Daniel, which is, of course, some years old, but still works. So, of course, this gives some advantages if you have containerized virtual PBX services in the background. Of course, with a Kamailio in front that is domain-based, you can have one SIP user multiple times, so several customers can have, e.g., the number 100 for their devices. Of course, you can have several locations per device because Kamailio is capable of doing this. And of course, which is also something nicely already mentioned before, is that there's a notification. So if two devices ring and you pick up on one device, the other device won't show you a missed call. But most of all, we are very happy to have security introduced with Kamailio, so everything is encrypted, but it's only encrypted on the edge, of course, so that internally we don't have this heavy lifting of the encryption. One nice thing, or one special thing that we have is due to this multi-domain setup, we use a Let's Encrypt wildcard certificate. The automatic renewal of that is not so easy, but thanks to a Cloudflare API that I can recommend, we're able to automate this process as well. And yeah, of course, we need a small picture just to illustrate a very simple but still useful use case. So you have a Kamailio with just one IP address, where several not customers but tenants can register their devices. So, for example, the customer Luke has two devices in two different locations, and Kamailio will route it to the Luke container, and layer has the same, but ends up in the layer container, giving us the opportunity to operate, like I said, one IP address, of course limited concurrent calls-wise with the ports and stuff that we already heard, but still very nice setup, and that's it. 30 seconds ahead of time, giving room for the next one.
Christoph from Vienna in Berlin, talking about railway GSM networks. No.
Yes, not no, yes, it's about railways. Good afternoon. Time is running, wonderful. First I say thank you to Markus to have the chance to put a few words here. I'm a Kamailio newbie, of course, and but I'm in the SIP domain since 2008. So this is, I hope, enough. Kapsch-Carrier.com, yeah, it's about railways, but it's also about mission-critical networks. That means fire brigades, police, military, and there are a lot of technologies, legacy technologies, GSM-R, TETRA, DMR, for example, and these have to be replaced by SIP-based solutions, of course. Yeah, I'm very short. We use the IMS modules of Kamailio. First message of this picture, we don't have an ICSCF in phase 1, so we are starting with this topic. We are not yet finished. There are a lot of questions open. And yeah, of course, input is always welcome. We do a primary, secondary routing with the dispatcher module and achieve a hot standby behavior in this case. Therefore, we had to implement the database mode DB only. This was not present in the IMS modules. This is on the way. We use a high available database cluster, and the PCSCF, we are currently investigating how to solve the problem at the GM interface. Should we give the user equipment 2 IP addresses via DNS, or should we use an intermediate load balancer? There are several solutions. We are considering that currently. And yeah, and the final goal, we want to connect the old legacy GSM-R network via the MGCF. Does anybody know what an MGCF is? Okay. And here the SCSCF with an interworking function. There we think to implement an own module for this interworking function. So this is not a plain 3GTP standard. This is some railway specifics. Yeah, that's all. Yeah, the main story. The GM interface apps for the Android devices, and the ISC interface for the application server, and the GSM-R et al. Are mission critical. Push-to-talk, for example, are services which are considered by our customers something like a closed system. And our customers, we are feeling, they want open systems. So we think to make this open here, to add space for third-party services, for example, with asterisk over the MX or the MW interface. And that's it.
Thank you. You were in time. Great. So, next on stage is ATLA from Norway. And I think we will see good stuff.
Try. I broke it before I even started. Isn't that what I always do? Okay, I just broke Markus's laptop. So I'm Atle from Norway, NextWay or from previously Telio. So I thought we'd just give some history first. Telio got started in 2003, founded by Alan Durek, who's also the founder of Wire, if you guys know that one. In our peak, we had roughly 300,000 users online. We started out with SIR 0811. How many of you guys have used SIR, by the way? Not really that many. Does anybody know what it's for? What it means? Yay! Yeah, right now we've got roughly 100K users online. We've got our own soft phones for Android and iPhone based on BearSip, which is written by Alfred Hegstad, who worked at our place for some years. We've got a WebRTC soft phone. We've got 4 SIP platforms. We're a white label partner in Netherlands, etc. Yeah. The newest Kamailio version we're running is 4.4, and the oldest SIR version is 094, or an M14, sorry. So our platform is basically fairly simple, the new one. We've got our user proxies, SIP trunk proxy, everything goes through our registrar / call router, out through an internet proxy, through an SPC, an application proxy with a VPBX platform, voicemail, etc. So to take it a little more advanced, this is kind of how it looks like if you go crazy. So I'm glad I didn't make this picture. I stole it from one of my colleagues. So yeah, I'm doing it quickly today. So on the Hall of Shame, good old Sir 094, running some Telio editions, compiled 2009. That's our Danish platform. Our old Swiss platform running Sir 094 T261, compiled in 2010. And the platform we shut down in January, which had been running for some time, if you guess what, or if you look at the uptime which is there, you can count out that it's a few days of online time. So, yeah, that's it.
Thank you very much. When I see the Astros version, I think tonight you should update it while in the hotel room. So, thank you very much. Stefan, last slot, and I think we're really in time, Daniel. So, give us feedback. Maybe we can make the slot next year and do some improvements or whatever.
Hello, I'm Stefan. I work at a company that I co-founded called Frafos, and our product is an SPC. But I want to talk about something different, community cellular networks. Yep. I had the ability to work a bit with some projects called Rhizomatica and TIC AC, and organizations from the US and Mexico, and they're running community networks, community mobile phone networks in mostly the networks that they are running are in Mexico in the south, and it's actually photos that I took myself, but the two top ones, because I had the ability to go there and meet them and really go to a place where this phone network is running. It's all run on open source software, and they the mission is, or they support communities who need or want to build and maintain self-governed and self-owned telecommunications infrastructure. And I think this is a really cool thing because it's a different model how to do telecommunication, not through massive companies who invest loads of money, not through governments, but through the people themselves. And they, to be able to do this, they work in 3 different realms. It's not only the technology, a lot is technology and empowering people to use and modify the technology the way that they want to do. But the other 2 big things is the social one, like organize a community or support the community in organizing themselves to take their telecommunications in their own hands. And the 3rd realm is the regulation, where they try to influence also the politics and the regulations so that they can get spectrum, that people can actually build their own networks. And this TIC network that they are running in Oaxaca has, I think, 17 or 18, 19 BTSs running now in a very mountainous area. And from the structure, it looks a bit like this. So you have the BTS and BSC in a community, in a village somewhere, which is mostly in like underserved areas. And then you have some terrestrial backhaul. I mean, they are standalone, so they can have local calls within the village. And then you have a terrestrial backhaul over some wireless link. So here on the left side, you see the Wi-Fi link for it. It goes over the internet to a data center where the connection between the different sites is done for long distance calls, and for intercommunity calls and long distance calls over SIP trunks to a PSTN provider. So inbound is simply the ID to IP in the script, and outbound the dispatcher is used. And what we did for another scenario where you have where you are really so far away that you don't have even like a Wi-Fi terrestrial internet link, but only a SAT link, and when you have really limited bandwidth, so for example only 128 kilobit, then you have to try to get as many calls as possible through it. But if you look at the packets on the right side, for an AMR packet, the header, a normal RTP header for every packet is much bigger than the payload. So what we did is, I implemented something in SEMS, the SIP Express Media Server, to multiplex and also batch and different packets of the same call and of different calls, and also to do header compression so that you only transmit what is actually needed. So there's a small checksum, there's a difference on the sequence number and timestamp, But this is done in such a way that only minimal, like in the beginning you transmit the whole RTP header, and then you transmit only what you need for it, and every couple seconds you transmit a whole RTP header. And you also don't need to transmit all the IP addresses all the time. So anyone that's working with some really low bandwidth links, like satellite links or so, maybe it should be like, look at this. It's a generic solution. SEMS is a back-to-back user agent. On the left side, normal SIP call comes in. On the right side, it's normal SIP, but RTP is multiplexed and batched, goes out, and you can use 2 instances to bridge that low bandwidth link. Yeah? So anyone who works in this kind of thing where the bandwidth is really constrained maybe can get some utility out of it as well. It's in the GitHub SEM server repository. And one thing that I'll be working on is voice over LTE. We're also testing out LTE networks. We have one like for data only running. And we want to replace this, like my idea is to very simply replace this Osmocom-based 2G stack with voice over LTE. And luckily I met Carsten and asked him a lot of things. So some of the questions are already solved. But maybe if some people want to collaborate, that would also be really nice.
Thank you. Thank you, everybody. But before we finish, I have some presents. Of course, ATLA, this is well deserved. Running a 0.9 point something and showing it in public, you deserve a banana phone. Of course, get some more. And number 2 and number 3, that was Paolo and Sebastian. You were the most accurate speakers. 5 seconds left, both of you. So another one. Sebastian. And the last one, I'd call it the late adopter prize, and that's for Christoph of Kapsch. Late to the party, but doing crazy stuff with Kamailio. Okay, that's from us, all from us.
Thank you, Markus. Really interesting